This summer, meet the magical mermaid at VGP Marine Kingdom from April 12th to May 31st.
Infertility impacts nearly 180 million couples worldwide. Certain factors involving the male account for around 50% of the reasons behind infertility. It can be the complete absence of sperm and semen ejaculate. It can be low sperm count, abnormal motility of sperm, abnormal shape and size of the sperm. The reasons are plenty. But one of the important factors behind these causes is the gene. There are around 20,000 to 25,000 genes in the human body. Now, a new study has found that the TEX13B gene, which is present in the X chromosome, is essential for sperm cell development and male fertility. The study by the researchers at CSIR Center for Cellular and Molecular Biology in Hyderabad was recently published in the journal Human Reproduction. Their discovery is that two mutations in the TEX13B gene, one of which was exclusively found in infertile men and the other was found more frequently in infertile men compared to fertile men. If you are wondering why this discovery is significant, well, when it comes to chromosomes, XX is female and XY is male, right? Men get X chromosomes from their mothers and Y chromosomes from their fathers. So the Y chromosome is where the genetic reason for infertility is usually looked at. But in this case, the TEX13B gene is present in the X chromosome. That means this gene is passed on from the mother to the child. A gene is made up of several DNAs and a genetic mutation is a change in a sequence of your DNA. This DNA sequence gives your cells the information they need to perform their functions. If a part of your DNA sequence is in the wrong place, if it is not complete or if it is damaged, you may experience symptoms of a genetic condition, something like infertility.
Initially, we looked at all the Y chromosome related genes because Y chromosome has a lot of genes and also it has a lot of repetitive sequence. So most often in 11 to 12% of the male infertility is due to deletion of the Y chromosome, either microdeletion or macrodeletion. When there's a deletion, it always removes some of the genes which are responsible for spermatogenesis. After that, we also looked at some of the known genes which have been reported elsewhere. Even after doing all this, we end up in a large number of cases where we don't have any clue that what was the actual reason for male infertility in some of the cases where they could not find either microdeletion or mutation in some of the known genes. Therefore, we went on to do exome sequencing. Exome sequencing means exomes are the ones which are all the coding region of the genes. We have about 30,000 genes in human, and we have sequenced using next generation sequencing method. We sequence all the coding region of 30,000 genes and compare the infertile individuals' exome sequence with the fertile individuals' exome sequence. Then we did very extensive analysis, and when we compared and we found that there are certain mutations which are present only in the infertile individuals but not in the fertile individuals.
Well, while the mutations are one thing, the loss of TEX13B gene reduces the respiratory ability of the cells. They also found that TEX13B controls energy metabolism in the sperm producing cells. Together, the researchers argue that this affects the formation of new sperm cells. Like I mentioned, this gene is passed on from the mother to the child. So here we are. Mothers can also be a reason for their son's infertility.
If you look at the societal perspective, always the mother-in-law blames the daughter-in-law because when she doesn't have the child. If you look at the scientific finding, in fact, that clearly demonstrates that rather the mother-in-law is responsible for some of the case. Now, I'm not saying that in all the case of male infertility. In some of the case, maybe percentage-wise, it may be very, very less. But in certain number of cases, in fact, mother-in-law is responsible for male infertility because she passing the X chromosome to her son. Therefore, son cannot produce the sperm.
Now, what this finding does is that it can help with the diagnosis. This is one more aspect to look at when screening infertile males with spermatogenic failure. But can this genetic problem be treated? Well, it is not so straightforward because genetic conditions are generally very hard to treat. Nevertheless, the diagnosis from this perspective can help with counseling the patients before implementing assisted reproduction techniques. So, to all mothers-in-law squarely blaming their daughters-in-law or sons for their infertility, remember that in all probability, you can very easily be a part of the problem and even responsible for it. Science says so.